Dear student, in our last lecture we were talking about electroplating and we had summarized what we do in electroplating, but the different steps involved in electroplating we have not gone through in detail. However, the entire material I have shared with you so that you can prepare your notes and you can know the different aspects of electroplating. But one aspect is very important, sandblasting in electroplating. We would like to discuss a little bit about sandblasting. This operation actually is required when oxide scale is to be removed from a metallic structure and when a comparatively roughened surface is required. But one thing we should keep in our mind, after sandblasting, painting should be there to make it more durable and so that it can give maximum protection. And this type of operation is desirable for any metallic structure, having a very large area covered for that. In that situation, sandblasting is very much effective. But unfortunately, in sandblasting, very expensive machineries are required, and the worker who are involved in sandblasting will be exposed to dangerous type of disease that is known as silicosis. It is actually an occupational lung disease which is developed due to inhalation of silica dust. This is all about actually sandblasting, which I wanted to share with you. Now let us discuss about electroless plating. Electroless plating. Actually, this is another approach in which deposition of noble metal from its salt solution is being made on an catalytically activated surface of less noble metal in the presence of a suitable reducing agent and without passing any electric current. Try to understand what we are doing. Here we are doing a metallic structure which is less noble in character, and we will allow a more noble metal to deposit on it using a suitable reducing agent, and no electric current will be involved in it. And the reducing agent we are using will have the responsibility to convert the metal ion into metal atom, which will then be actually adhered, coated, plated about the metallic surface with a uniform thickness and very thin coating layer. Most commonly used electroless plating are electroless nickel plating, electroless copper plating. This is in brief about our electrolyte plating. Now we will be talking about hot dipping, another approach. Hot dipping. The name itself is telling. Suppose it is a tank in which molten metal will be there. That is your molten coating metal, and at the surface there will be molten reflux, and generally here we use ammonium chloride kind of thing, refluxing agent, and sometimes zinc chloride is also used. Try to understand. This is a tank container in which molten coating metal as coating material which is being used on the metallic surface to be coated, and at the surface it will be covered with molten reflux of ammonium chloride by zinc chloride. The purpose of using that is molten reflux are, number one, it will initially clear the surface of the base metal for good adherence, and secondly, this layer will also prevent the oxidation of molten coating metal. Now what we will do, the metallic surface to be coated is being dipped into it, and as a result of which, after some time, the metallic structure will get a protective thin layer of coating material. Actually here this approach is very much suitable for low melting solid. I want to mean as coating material like zinc, aluminium, lead, or iron and steel. I want to mean if you are having a metallic structure made of steel or iron, it should receive a thin coating of aluminium, zinc having low melting point. Generally copper has a higher melting point, and to apply this kind of coating, two approaches are available. Number one is galvanizing, and number two is staining. This will be discussed in our next lecture. I am very much sure that what we have discussed today, blast furnace, electroless plating and hot dipping, these are the basic aspects of all. You please go through it. If there is any doubt, we will clear it in our next lecture. Thank you very much.